Okay, so let's dive right in. We're looking at this piece of tech, the NTI E-PST500IS, which is an intrinsically safe pressure sensor transmitter. It sounds like a total mouthful, but I think our mission here is pretty straightforward. What does intrinsically safe actually mean for someone using this?
Yeah, exactly. I mean, the whole point of this device, its entire reason for being, is to monitor pressure in places where,
Yeah.
well, where the air itself could just ignite. It's all about making sure the instrument can't be the thing that starts the fire.
So intrinsically safe is the key phrase. We're not just talking about a sensor that's tough or sealed off, are we?
No, not at all. That's a huge misconception. It's really about actively limiting the energy, the
Hmm.
electrical energy, the thermal energy. So this thing, with its Class 1 Division 1 rating, it's for areas where flammable gases or vapors are just there.
Yeah.
During normal operations, the design itself makes it physically incapable of creating a spark, even if it has a major failure.
Right. And looking at the design specs, it's 316 stainless steel with a 18-inch BNPT connection, which for anyone not familiar, that specific thread type is all about creating a super tight, rock solid seal.
Critical for keeping volatile stuff contained.
Yeah, and we also saw it's TAA compliant. That's a big deal for, quality in government contracts.
Right, but here's the kicker. This is where the complexity comes in. The sensor can't do its job alone. It explicitly requires an external box, the EISDB, intrinsically safe barrier.
Wait, hold on. So you buy this, what, $2,600 sensor, and it isn't actually safe out of the box.
That's right.
You have to buy something else to make it work safely.
Exactly. It's sold separately, and that barrier is, well, it's the heart of the safety system. It sits outside the hazardous area, and it physically limits the voltage and current going to the sensor. So even if a wire shorts out, there's just not enough juice to make a spark.
Okay, that crystallizes it. It's a safety chain. It's a whole system, not just one device.
It is, and there's more to that chain.
Right, because it also needs to be powered by specific NTI units like the E2D or E5D.
Correct. Those act as the primary current limiters. It's another mandatory layer of that control power structure.
And there's one more piece of hardware mentioned, the ES420MA24V converter. Why that extra step?
That's basically the translator. It turns the raw signal from the sensor into the industry standard 420 milliamps. It's the language that all the industrial control systems understand.
So when you add it all up, the separate barrier, the specific power supply, the converter, that's how you get to that price tag of $2,600.
Yes. And that's before the cost of the other components. Don't forget the maximum cable length, too, 1,000 feet.
305 meters. So you're
Right.
paying for guaranteed compliance.
For engineering certainty. So to sum this up, the E-PST500IS, it's really not just an expensive sensor. It's one component in a very complex, interconnected system, a system with a single purpose, making sure your measurement tool doesn't accidentally cause a catastrophe. Which leaves you with a really interesting thought to chew on. If just maintaining something as basic as pressure monitoring in an explosive atmosphere requires all these specific external barriers and converters, you have to wonder what other hidden costs or regulatory complexities are engineers navigating every single day just to ensure baseline safety in these settings. It's never just about the cost of the one shiny device itself, is it?